Hello everyone. Today we are going to understand about the combinational and sequential circuit using Verilog. So first of all, let's start with what is Verilog. Verilog is not a programming language, at least not like any of you are used to. It is a hardware description language, which means it is a textual way to describe digital circuits. So now let's move on to the Verilog syntax. First, everything in Verilog starts with a module. Think of a module as a container for your circuit, where you define what goes in and what comes out. We begin with the keyword module, followed by a name that describes the circuit. Inside the parenthesis, we define the inputs and outputs. Finally, we end the module with the end module. Next, we need to declare the inputs and outputs. This is where we define the direction of signals in our circuit. You can also specify multi-bit signals like this. Verilog allows you to specify the width of the signal using square brackets. In this case, we are working with a 4-bit input and 8-bit output. Verilog has two main data types, wire and register, spelled as REG. Wire is used for signals in combinational circuit, and REG is used to store values in sequential circuits. Here's how you declare them. Now, for combinational logic, we use a sign statement. This statement is used to define a relationship between signals similar to an equation. So now that we understood the basics of Verilog, let's move on to an example by implementing a half adder using Verilog code. Before diving into the code, let's first understand the truth table of half adder. A half adder has two inputs, A and B, and two outputs, sum and carry. As you can see, when both A and B are 1, the sum becomes 0 and carry becomes 1, which happens when you add 1 plus 1 in binary. And now let's start with the combinational circuit implementation by writing the Verilog code. We start by defining the module half adder comp, or you can define it by yourself. The inputs are A and B and the outputs are sum and carry. Then we will calculate the sum using XOR operator. In binary addition, the XOR gate gives a 1 if either A or B is 1 but not both. Then we'll calculate the carry using AND operator. The AND gate produces a 1 only when both A and B are 1. Then we'll complete our syntax by AND module. Now we will see the half adder code using if else statement. Similarly, we will declare the module, then the inputs A and B and outputs sum and carry. Both outputs are declared as RAG because we are updating them inside an always block. Then we will begin the always block. This block monitors changes in the inputs. When A or B change, the block executes. After that, the if else condition checks if A and B are same. If they are same, the sum is 0. If they are different, the sum is 1. Then the carry is determined using the condition if A and B. This checks if both A and B are 1. If both are 1, the carry is set to 1, otherwise it is 0. Then we'll complete our syntax by ending the always block and using the end module. Now you may all have doubt that how to read this syntax. So let me explain it to you. In Verilog, this tick mark symbol is called size-based separator. 1. This specifies the number of bits. In this case, it's 1 bit value. The B denote the following number is in binary format. Verilog allows specifying numbers in different bases like binary, decimal, hexadecimal, and octal. And last 0. This is the actual binary value. In this case, it is 0. If it were one tick mark be 1, it would represent a 1 bit value of 1. Hope you liked the lecture. Thank you all.